For 6.4, we are continuing our study with vectors, and we will be looking specifically at dot products, as well as how to use that to find other information. So your definition of a dot product: if you have two vectors, u and v, components u1, u2, v1, v2, then u dot v is simply multiplying those first components, so u1 and v1, multiplying the second component, so u2 and v2, and adding them. This will always be a scalar, which is just a fancy way to say a number. It will not be a vector. So it won't have any direction, just be a number with magnitude. We have some properties of our dot product. First one, does not matter which order you multiply them in. U dot v is the same as v dot u. And that's a fancy way of multiplying vectors. So the only way we can multiply a vector times a vector, we do call it the dot product though. If you do your vector 0, so that would be 0, 0 times any vector v, then my answer is just going to be the number 0. It works with your distributive property as well, so if I have u times the sum of v and w, I could do u times v and u times w, and then add those two answers. Or you could have added your two vectors and then multiplied by u. If you multiply a vector by itself, it will be the magnitude squared, which does kind of make sense if you think about your magnitude is your first number squared and your second number squared, and then you add them and take the square root. If I ignore taking the square root and I just did the first number squared plus the second number squared, that is my dot product of my vector and itself. And then if I have c, where c is a scalar, so a number, then multiplying it, just like if I was multiplying anything, if I had 2 times 3 times 4, I'm not going to do 2 times 3 and 2 times 4, even if it was written like this, and only multiplying each thing once. So I could separate it as c times u and then multiply by v, or u times c times v, or again, like the way it started, u times v and then multiply that by c. Alright, find each dot product. So I'm going to do one with you, then I want you to actually do the other ones. So I multiply my first two components, so 4 times 2 is 8. My second component is 5 times 3, so that's 15. Then I'm going to add those, so that is 23. That is my dot product. Take a second and try the next two. For the second one, you should have gotten 0, and for the last one, you should have gotten -6. For these, I'm giving you your vectors up here, u, v, and w. I want you to do for number 4, u times v and then times w. So u times v, I'm going to do that first. So that would be -1 times 2, so -2, plus 3 times -4, so that's -12. I still need to multiply that by my vector w. -2 plus -12 is -14. That I am then multiplying by vector w. Vector w is 1, -2, so I can just distribute that -14 to each of those. And that's my answer. Try number 5 and then come back and check it with what I have done. I got -28 for number 5. For this first one, number 4 here, I did get a vector as my answer because u times v, yes, gave me a scalar, gave me that -14, but if I do a scalar times my vector, that is going to be a vector. Over here, 2 times v, scalar times a vector, was still a vector, but when I multiplied those two vectors, I did get a scalar as my answer. The dot product of u with itself, So if u times u is 5, what's the length of u? Go back to your properties. There should be one that says dot product of a vector in itself equals its magnitude or its length squared. So this simply equals my magnitude squared. If I want to know the length of u, I will just square root it. So the square root of 5 is my length or magnitude of u. The angle between two vectors. There's a fun formula with that. We did this last section. We had to do law of cosines. It does still build off of that, so let me give you a quick little picture here. If I have two vectors, let's say this is vector u and this is vector v. Here's my angle between them. Last time, if you recall, we made a triangle and did like this vector here that was u minus v, and then we did law of cosines. You don't need to do law of cosines for this one. My formula for this, without having to find that third side, making the triangle and all that, is still going to use cosine. So cosine of that angle is my dot product. This is why we didn't learn this formula yet. We didn't know the dot product of those two vectors, u and v, divided by their magnitude. So magnitude of each one, so I would need to multiply that. So find the angle between these two. Take a minute, and I want you to try that on your own. Find your dot product, find your magnitudes. First off, for my dot product, and I will write this one out a little bit more, I'm going to be doing 4 times 3, and then 3 times 5. So 4 times 3 is 12, 3 times 5 is 15. So my numerator is now 27. For the denominator, I need to do my magnitude for each one. If you want to, do that off to the side, or do it right here, but the magnitude for u is the square root of 4 squared plus 3 squared, so 16 plus 9, which would be 25. Oh, that's just 5. Magnitude for v is going to be the square root of 3 squared plus 5 squared, so radical 34, which I can't simplify. So this is just 5 radical 34. You can rationalize this if you want, but this isn't my final answer, so there's really no need to rationalize it. Simply do your cosine inverse of that. Do be careful with parentheses around that denominator. So when I do cosine inverse of 27 over 5 radical 34, I get 22.2 degrees. That is the angle between those two vectors. The last thing we're going to look at with our vectors, and specifically using their dot product, is orthogonal vectors. Orthogonal is a fancy way of saying perpendicular. So the vectors u and v are orthogonal if their dot product, so if u times v, is 0. So if I say, are these orthogonal, all you need to do is find their dot product. If it's 0, then the answer is yes. If it's not 0, then it's not orthogonal. Sometimes it will ask if it's parallel. For that, I would still start by doing my dot product because that's the easiest way to go. If I don't get 0, then I'm going to check, kind of thinking of like my slope. Like this guy was right 2 and down 3, so my slope has the rise over the run. This slope would have been 4 over 6, which I would have reduced to 2 over 3. Those are not the same, so that one's not parallel. They're negative reciprocals, so they're orthogonal. I do expect you to do orthogonal by checking their dot products, but if it goes further and asks if they're parallel, make sure you're checking essentially what direction they're going in. If they go in the same direction, then yeah, they're parallel. I want to go back to this guy for just a second because there's one thing that comes up on the notes or sorry, on the practice that has tripped up several people. I'm trying to remember exactly what it says, but I think it says that if the angle between is, let's just say 20 degrees, and the magnitudes are, and I'm just going to say 2 and 15, then what is the dot product? Plug them into your formula. You know your angle between, so you can plug that in there. You know your magnitude, so you can plug those in there. Just multiply. In this case, it'd be what, 30 times cosine of 20? Whatever that is, that's your dot product. I didn't ask specifically what each vector was. I asked for the dot product of them.